Welcome to the Cypress College Math Review on factoring quadratics. We're going to look at three different cases here in basic factoring of quadratic expressions. In the first case, all the terms are positive. In this example, we have 6x squared plus 29x plus 28. So what we're going to attack first here is to look at the leading coefficient. In this case, it's 6, and we're going to list all the possible factors. So we have 1 times 6 would give us 6. 2 times 3 would give us 6. Next, we're going to list all the factors of the constant term, the third term. So all the factors of 28 would be 1 times 28, 2 times 14, and 4 times 7. Those are the ways that we can make 28. Now what we're going to do is look for combinations of products that will add up to be the middle term, which is 29. So for example, if we first try to think of maybe 1 times 28, which is 28, and 6 times 1, which is 6, but 28 plus 6 is equal to 34. Now 34 doesn't work because we need 29. So that's not the right ones to pick. And so you'll go through choosing factors and trying, plugging in and seeing which ones might work. And in order to get 29 here, we see one way to make it work, and we can go 3 times 7 because we know that would be 21, and we have 2 times 4 and we know that would be 8, and 21 plus 8 is equal to 29, exactly what we need. So now here's how you get your factors from this. The 2 and the 3 tell you the coefficients of the x term in each factor. So we come down here, we make our parentheses, and we put 2x and 3x. And again, that comes from those first two factors right there. Next, to get which number is going to go here and which number is going to go here, you look and see who each of those factors is tied to. So for example, the 3 is tied to the 7. So that means when you come down here, you need the 3 and the 7 to be what are multiplying. And since I need them to be a positive 21, I know I'm going to put plus 7 right here. And again, that's because the 3 had to be tied to the 7. Now we see that the 2 has to be tied to the 4, and again, they have to be positive, so that's going to be a positive 4. And when you FOIL that back out, which you should always do, we check first times first is 2x times 3x is equal to 6x squared. You want to check that your outer term, which would be 2x times 4, which is 8x, and your inner term, which would be 7 times 3x, which is 21x, does indeed add up to be the 29x. And then last times last, we have 7 times 4 is 28. Okay, let's try this next one here. 15x squared plus 26x plus 8. And we're first going to list the factors of 15. So we have 1 and 15, 3 and 5. Then we're going to list the factors of 8. So we have 1 and 8, 2 and 4. And then we begin our search for the combination of product pairs that will add up to be the middle term, which in this case is 26. So we use trial and error. and we would discover that we're going to get 5 times 4 is a positive 20, and 3 times 2 would give us a positive 6, and 20 plus 6 adds up to the coefficient we need, which is 26. So once again, we take the first two factors, and they're going to give us the coefficients of the x terms. So we get 3x and 5x, and then we see whoever those factors are tied to. So because the 5 is tied to the 4, then we have to make the 5 tied to the 4 down here. So we get a plus 4 because we want their product to be a plus 20. The 3 has to be tied to the 2, and we want their product to be positive 6. So down here, I want the 3 to be tied to a positive 2. In the second case, we're going to look at trinomials where the last term is positive, but the middle term is negative. So let's consider this example. We have 10x squared minus 23x plus 12. If we get the factors of the leading coefficient, we know we could have 1 times 10, or we could have 2 times 5. Then we consider the factors of the constant term, 12 in this case. We know we could have 1 times 12, we could have 2 times 6, or we could have 3 times 4. And now, as always, we'll go through looking for product pairs that are going to add up to be the middle term, which in this case is negative 23. So as we go through and we try the various factor pairs, for example, we could try 1 times 12, which is 12, and 10 times 1, which is 10, but a negative 12 and a negative 10 would give us negative 22, not negative 23. So you do guessing and checking, you go through all the pairs, and you would discover that we're going to need 5 times 3, and we'll need a negative 15 from that, and 2 times 4, which would be a negative 8. Now, negative 15 plus a negative 8 gives us negative 23. So now we are ready to make our factors. And we know that we get the coefficients of the x terms from the first pair. So we have 2x here and 5x here. And then we tie together the factors. So the 5 has to be tied together to the 3, and in order to get a negative 15, we're going to have to make that a negative 3, so that we have 5x times negative 3 to give us negative 15. The 2 has to be tied together with the 4, and again, because we have to get negative 8, we know I have to make this a negative 4. And when we do our checking, 2x times 5x gives us 10x squared. We have 2x times a negative 4, that's our negative 8x. We would have negative 3 times 5x, that gives us our negative 15x. That's going to give us our middle term of negative 23x. And then we will have negative 3 times negative 4, which is going to give us positive 12. In the next example, we have 20x squared minus 67x plus 21. So we get the factors for the leading coefficient, which is 20, we have 1 times 20, 2 times 10, 4 times 5. The factors of the constant term are going to be 1 and 21, 3 and 7. We start going through looking for the product pairs that are going to add up to be negative 67. So in this case, we can see 20 times 3 is going to be 60, and we're going to need it to be negative 60. And 1 times 7, right? But we need it to be negative 7. This is going to be the two coefficients of the x term. So we're going to have x and 20x. And the 20 has to be tied to the 3, and we have to get a negative 60, so we're going to need to make that negative 3. And the 1 has to be tied to the 7. We need them to be negative 7, so we're going to need a minus 7 down here. And as we check our inner and outer terms, we see we're going to get a negative 7x from the outer term. We're going to get a negative 60x from the inner term, and those two add up to be negative 67. Now in this third case, we're going to look at what happens when the last term, the constant term, is negative. It starts off the same. We get the factors of the leading coefficient, so that's going to be 1 and 12, 2 and 6, 3 and 4. Next, we get the factors of the constant term, ignoring the negative sign for just a moment. So we have 1 and 10, 2 and 5. Now, what the negative sign in front of the 10 tells us to do is that when we find our product pairs, we want to find product pairs whose difference is going to be 7. But remember, it's controlled by the negative sign being here, not this negative sign in front of the 7. Because the 10 is negative, that's why we're going to be looking for the difference in our product pairs. So as an example, if we start to just try some out, if we took 12 times 1 to get 12 and 1 times 10 to get 10, the difference would be 12 minus 10, which is 2. But we need the difference to be 7. So you would go through trying various combinations, and we would get to, let's see here, we have 3 times 5 is 15, 4 times 2 is 8. Now the difference between 15 and 8 is 7. Now we have to consider the sign of the middle term is negative. So what we really need is the sum of these two factors to be negative 7. So that means we're going to need a positive 8 and a negative 15 to achieve that. Now we're ready to make our factors. We know that the 3 and the 4 are going to give us the coefficients of the x terms in our factors. So we'll have a 3x in the first factor and a 4x in the second factor. And now we connect them to their product pairs. The 4 is connected to the 2, and we need it to be positive 8, so we're putting a positive 2 here. The 3 is in a product pair with the 5, and we need that product to be negative 15, so we're going to have to put negative 5 here. And we can check the foiling out fully if we want to. We know 3x times 4x is going to give us 12x squared. When we check the outer and inner terms, we're going to have 3x times negative 5 gives us the negative 15x that we need. We know that the 2 times the 4x is going to give us the positive 8x that we need, and those two together add up to give us negative 7. And then when we check last times last, we get negative 5 times a positive 2 is a negative 10. In our last example, we have 8x squared plus 2x minus 15. We get the factors for the first term, which is 8x squared. So we need 1 and 8, 2 and 4. The factor pairs for 15 are going to be 1 and 15, 3 and 5. And now, because the constant term is negative, we know that we're going to be looking for the difference in our product pairs. And we want that difference to be 2. So as we look at all the possibilities here, we can see that we have 4 times 3 is 12, 2 times 5 is 10. The difference between those is positive 2, and to get that positive 2, that tells us to make the 12 positive and the 10 negative. The 2 and 4 are going to be the coefficients of the x's in our factors. So we'll have 2x, and we will have 4x. Then we connect them to their partners. The 4 has to be connected to a 3. I need the product to be positive, so I'm going to make it positive 3. The 2 has to be connected to the 5. I need that to be negative 10, so I'm going to insert negative 5 there. We could check out our foiling, of course. 2x times 4x is 8x squared. We've got the outer is negative 10x. The inner is positive 12x. That gives us our positive 2x. And then last times last gives us the negative 15. Now you can try these 5 problems here for some extra practice. Give them a try and then check the answers that are given below. Sure hope this lesson helped you, and good luck with your quadratic factoring.